Alright, let's get going pretty quickly here. Number 10 from 8.4, the integral of the square root of x squared minus 4 over x dx. So we need to make a decision about what trig function is going to get substituted in here. Well, actually this problem tells us what it's going to be. It says let x be the secant of theta times 2. 2 times the secant of theta. Okay, so we are going to put that in here for this x. We do need to also make a substitution for x squared. So what's x squared? That's 4 secant squared theta. And the last thing that we're going to need to replace that's with respect to x is dx. So dx is going to be 2 times secant theta tangent theta d theta. So here are all the things we're going to use to replace everything in the integral. And we're going to talk about why did we choose 2 secant theta in just a minute. So the square root of, now x squared is going to go in here. X squared is 4 secant theta. And this is going to get, this should be a squared here. And minus 4 over x, which is 2 secant theta, and then times dx, which is 2 secant theta tangent theta d theta. Okay, I'm going to not use the colors anymore. I think you see where everything went in the substitutions that were made. So we'll just kind of clean this up. Let's factor out a 4. We get 4 times secant squared theta minus 1 over 2 secant theta times 2 secant theta tangent theta d theta. Start cleaning things up. 2 secant theta is going to get canceled out. And so at this point I'll talk about why did we choose 2 secant theta. Well, let's talk about why did we choose 2. Well, when all was said and done, after we chose 2, the nice thing was that we wound up having a 4 here and a 4 here. When we factored out that 4, we were left with a minus 1. The minus 1 is key. 1 is crucial in these Pythagorean identities. You really want to have a 1 in there. So that's why we chose to have 2, because 2 comes in here, it gets squared, turns into 4. Now it's in common with this 4. So you want to choose something that's the square root of this number when it's this simple substitution. Why did we choose secant? Let's imagine that we had chosen sine instead. Well, we would have done all this work, everything would have been the same except for this would be sine squared theta. Is sine squared theta minus 1 any kind of identity? You can take a look, and it's not. The common one that we use most often is secant squared theta minus 1. So we chose secant because once we square it and factor out a 4 and come down here, we have secant squared theta minus 1, which gets replaced by tangent squared theta. That's the best part of the whole thing. So now we'll clean this up even more. The square root of 4 is 2. This is going to change to tangent squared theta. And what's the square root of tangent squared theta? It's just a single tangent theta. We've canceled these out already, and we get another tangent theta, so I'm just going to make this squared d theta. And I pull out this constant. And what should we do here? What's the integral of tangent squared theta? You could try a few different things and find out that probably the easiest thing to do would be secant squared theta minus 1. And then do d theta. So we can see that we're going to wind up with this integral minus this integral. You're going to get 2 times. The integral of secant squared theta is tangent theta. And the integral of negative 1 is going to be negative theta. And plus c. So there's this feeling like, oh yeah, we got rid of the integral sign, so we are good. This is fantastic and our work is done. But remember that we originally took things that were x's, made them in terms of theta, so now we have to go the other way. We need to put the x's back where they're supposed to be. So 2 times, how in the world are we going to find the tangent of theta? All we know is about the secants, and we got a tangent here. We could solve for that, except the problem with that being that if we isolate tangent over here, we're going to wind up with d theta, dx over here, a secant of theta, and it's just not going to work out very well. So in order to find out what the tangent of theta is, let's use this. This is the most basic piece of information we have about the relationship between x and theta. So if x is equal to 2 secant theta, then secant theta is equal to x over 2. Secant theta is equal to x over 2. So somewhere out there, there's this angle, and it has a secant of x over 2. I'll show you that angle. It's right here. Here it is. It has a secant of x over 2. What's the secant? It's the reciprocal of the cosine. The cosine is adjacent over hypotenuse, so the secant must be hypotenuse over adjacent. Hypotenuse over adjacent. What's this side then? Well, it's going to be x squared minus 4, if we use the Pythagorean theorem to find that. So the tangent of theta is opposite over adjacent. Tangent of theta is the square root of x squared minus 4 over 2. Okay, so now what's theta? Theta can be solved for using this function here, this relationship. Theta is going to be the inverse secant of x over 2. So theta is the inverse secant of x over 2. You could distribute this to if you want to, or not distribute it. Either way you want to go. Yeah. Okay. Just checking my work there. It's all good. Alright. So quickly, let's do one more in this video. It's going to be number, what do we say? 26. The integral of x times the square root of 16 minus 4x squared dx. What should we put in for x? We're going to make a substitution. X should be, well, remember we're going to pick a number, we're going to pick a function. Okay? So let's figure out what that's going to be. The nice thing is going to be, when we get down and do a bunch of work, at some point we're going to wind up with the square root of 16 minus what? 16 times some trig function, so that we get to factor out of 16, and we wind up with 1 minus some trig function. Okay, so we'd like to wind up with this number being 16. How can we wind up with a number that is 16? Well, whatever number I choose to go here is going to get squared, it's going to get multiplied by 4, and that needs to be 16. So I need a 4 times 4, so in order to get 4, I should choose 2. What trig function should I use? Well, remember it's going to be 1 minus that trig function, so the trig function we like to have there would be sine squared theta. So let's do sine theta. It'll get squared when we put it in here. So x squared is going to be 4 sine squared theta. And also we need to replace dx. dx is 2 cosine theta d theta. All right. And so now let's put everything in. X is 2 sine theta. X squared is 4 sine squared theta. Dx is 2 cosine theta d theta. 2 sine theta times, we know this is going to be a 16. Let's factor out that 16. 16 times, well, this is going to become a 1. This will be factored and become negative sine squared theta times 2 cosine theta d theta. 2 sine theta times the square root of 16 times, well, this is going to be changed to cosine squared theta. 2 cosine theta d theta. Alright, let's simplify this further. 2 sine theta times the square root of 16, which is 4, times the square root of cosine squared, which is cosine. And then multiply all of this by 2 cosine theta d theta. Let's multiply these numbers together, pull them out as a constant. 2 times 4 times 2 is going to be 16. Cosine times cosine is going to be cosine squared theta. We're left with a sine theta d theta. Well, this is of the form u squared and almost du. In order to be du, though, in order to be the derivative of cosine, this needs to be negative sine. So we need to put a negative out here to balance that out. So now we have u squared times du. Negative 16 times, well, what's the derivative of u squared times du? It's just u to the n plus 1 over n plus 1 plus c. All that's left to do is, well, we only have one thing with theta in it. That's nice. We need to find out what's the cosine of theta. Again, we know that x is equal to 2 sine theta from up here. That's what this is. So sine theta is equal to x over 2. Let's create that angle. That angle theta has a sine of and opposite over a hypotenuse of x over 2. So what's this side? It's just going to be the square root of 2 squared, so the square root of 4 minus x squared. So the cosine of this angle is going to be adjacent over hypotenuse. So it's going to be negative 16 times the cosine, which is the square root of 4 minus x squared over 2. We're going to raise that to the third power, and we're going to divide this by 3, and we can add c. So what do we say? Negative 16 times 4 minus x squared to the 3/2 over 8. Okay. If you possibly got lost here with raising this to the 3/2, just review changing between radical form and rational exponent form. Okay, that's going to do it for this video. There will be more to come. All right, goodbye.